Hey, welcome everybody. First of all, hopefully everyone is staying healthy and being safe. Um, and I'm not sure how much longer this is going to last, but it seems like it's going to be long term. So I need to add a few things before we get started. The reason why I enjoy IXL is because, it helps me check whether or not you understand the material. All right. Second thing is that I know that there are places where you can go to find the solutions. All right. In many cases, I feel as though when I look at how long it takes you to do the problems, I can generally tell whether or not you're using an outside source. All right. So again, you're doing yourself a disservice if you're just typing things in on a computer and it's just spitting out the answers. All right. I really think the work is incredibly important, and it is going to help you be successful next year. So please keep that in mind. I'm observing IXLs, the amount of time it takes, and how much or how many problems that you've done. All right. Now, I decided this week that I would kind of go through the IXL myself, every problem. And what I did was I worked those solutions. And then what I did was I just copied or took a screenshot so I could show you it's not that difficult. Now, all of these problems are from the IXL. And so I would want you to kind of work them exactly the way I am doing. All right. Now we have 3 IXLs, all right, that I need to work on. Now, the first IXL is something new because it was square roots, and right before the pandemic started, some of us got to this and some of us did not. All right, so I'm reviewing everything. The second and third IXL we've already done before, all right? And it's how to solve a quadratic by the zero property and how to solve a quadratic by factoring, all right? Because it's so important, I'm going to go ahead and just review that topic, all right? It's all over the SAT. It's all over the ACT. It's something you do in all upper level math classes, so you need to be a master of it, all right? So please, be honest with yourself, all right, and work the IXLs the way they are meant to be worked, all right? If you have any questions or concerns, you can personally email me, all right, and I'll be happy to discuss with you problems I've been having, all right? So first of all, number 1, solving for R. Now, most people think that the only possible answer is 3 because 3 squared is 9. But there's another number when you square it, it's 9, and that is what? -3. All right? So how do you remember to put the plus or minus? Well, the power tells you the number of solutions. So when we say r squared equals 9, the first thing that comes to mind I would want you to say, hey, is this. Is because it is r squared, there's automatically 2 solutions. All right? Now, how do you undo a square? You take the what? You take the square root of both sides. All right? But you have to remember when you take the square root of a variable that we always say plus or minus 3. All right? Plus or minus 3 is the solution for r squared equals 9. Now, just a quick review. If it's just an r squared or an x squared or an a squared, you can simply take the square root of both sides, and then you have to remember to include the plus or minus. All right? So let's move on. Number 2. All right. Now for number 2, what I tell kids is you want to isolate the h squared in this case. So we're going to add 49 to both sides. All right? And when you add 49 to both sides, you end up with h squared equals 49. And then we can do what? We can take the square root of both sides, square root of both sides. So we'd say h is equal to plus or minus 7. All right? Now again, I'm not suggesting that you have to show the work on that. I am saying that you have to remember that it's positive 7 or negative 7. And if you wanted to write it as h equals 7 or h equals negative 7, that's okay as well. All right? Let's check out number 3 now. All right? So again, remember our objective is to isolate the square term. When I isolate the square term, I have to add 54 to both sides, add 54 to both sides. So I end up with r squared is equal to 144, right? Now I take the square root of both sides, so r is equal to plus or minus 12. All right? Question number 4, solving for j. All right? To solve for j, again, our objective is to isolate the j squared first. So to do that, I have to add 99, add 99, and so now I end up with 100 j squared is equal to 25. I have to divide by 100, so j squared equals, and 25 over 100 is 1/4. Now we take the square root of both sides, so j is equal to plus or minus 1/2. J is equal to plus or minus 1/2. Okay? So again, not too bad. Same rules apply. All right? If it's just a variable, you're always taught to isolate the variable. So now you're just isolating the square term, and then you just take the square root. All right? So let's take a look at number 5. Sorry, for some reason it came out small. All right? And it's also a little blurry. So let's go ahead and rewrite this. 9j squared equals 16. I'm not sure why that happened. All right, but again, we've got to isolate, so we're going to divide by 9, divide by 9. So now j squared equals 16 over 9. Now let's go ahead and we will take the square root of both sides. Square root of both sides. And remember, when you take the square root of a fraction, which I didn't mention earlier, I should have, it's kind of like writing it as the square root of 16 over the square root of 9. So this becomes plus or minus 4/3. All right? Plus or minus 4/3. All right? Let's check out number 6. Okay? Again, it's a little blurry. So I'll double check you. 4y squared minus 25 equals 0. All right, again, we're going to isolate the y squared. So I'm going to add 25 to both sides. So you're able to say 4y squared equals 25. And then I want you to be able to say y squared equals 25 over 4. And then square root of both sides. So y is equal to plus or minus 5/2. All right? So again, simple, simple, simple. All right? Now, how many real solutions? All right? Now, in this case, all right, the original problem was supposed to look like y squared plus 97 equals 0. All right, so if you isolate, you end up with y squared equals negative 97. Now, the problem here is when you take the square root, there is no number that equals the square root of negative 97. In other words, you cannot have negative underneath the radical. When you take Algebra 2, we'll introduce it as an imaginary number. But for now, all right, the only thing I want you to remember is that it is no real solution. All right, no real solution here. All right. Again, we could write it like that. Okay? Now let's look at number 8, where it says y squared plus 97 equals 98. Subtract 97. Y squared equals 1. Now when you take the square root, you get plus or minus 1. So this has what? 2 real solutions. All right? Because the answer is plus or minus 1. All right? Now, the next one. All right. What I want you to do for the next one is I want you to write down, I'm going to change a little bit. Sorry about that. I want to write y squared minus 16 equals negative 16. All right. So now what I want to do is I want to add 16 to both sides. So now I end up with y squared equals 0. Now here, when I take the square root of both sides, I end up with y equals, now it doesn't make sense to say plus or minus 0. All right, so in this case, we say there's really just one real solution. All right, but what I want to tell you is that, again, there's always supposed to be what? Two solutions, because it's to the second power. So what we do is we say this is called a double root. And that means that just y equals 0 twice. All right, that's how they get around that rule. Okay, so again, this would be nice if you remembered this as a double root. All right, there's one real solution, but it's considered to appear twice. Okay, so let's continue on. All right, now we're in the next IXL, and the next IXL is solve using the zero property. All right, now remember I taught you this earlier. All right, the zero property just means if you have two things that multiply to get 0, either the first thing is 0 or the second thing must be 0. Okay? Does anybody have any questions with that? All right. Now, again, let me say that one more time. If two things multiply to get 0, one of them has to be 0. All right? Now, like I said, we've done this already. All right, but it's a complete review, and I just want to make sure, because it's so important, that you understand completely what we're doing. All right? So how do you solve it? You just set the individual factors equal to 0. So you say x equals 0, and then you say x plus 9 equals 0. All right, then you just solve them individually. All right, so this first one has already been solved for us, but the second one you just subtract 9, and you guys are good enough to just write x equals negative 9. All right, so these are the two zeros, all right, or the solutions. All right. Same thing with number 11 now. We just set this factor, we set this factor. So I want everybody to write down r plus 1 equals 0, r minus 7 equals 0. Then you just say r equals negative 1 or r equals 7. Okay. A little bit harder now. We have now just two steps, but we just say 8g plus 7 equals 0, 8g minus 7 equals 0, and then we just go 8g equals negative 7, g equals negative 7/8, and over here 8g equals 7, so g equals 7/8. So generally what happens is we just say g is equal to plus or minus 7/8. Okay? Okay, nothing really has changed. Okay? So again, we just set the individual factors equal to 0. And now j equals negative 5, or 4j equals 5, j equals 5/4. Alright? So these are our two solutions. J equals negative 5 and j equals 5/4. Okay? Next, nothing has changed. We just say k plus 9 equals 0, 4k minus 1 equals 0, k equals negative 9, 4k equals 1, k equals 1/4. And again, those are our two solutions. All right? Very, very simple. Same process over and over and over. All right? And again, cannot stress the importance of this lesson. Please take the time, do the problems. You'll be grateful in the future that you did and that you're expert at these. J minus 5 equals 0. 2j minus 7 equals 0. So j equals 5. Or 2j equals 7. J equals 7/2. Okay, once again, j equals 5. J equals 7/2. Again, set them individually. 6s equals 0. 2s minus 5 equals 0. S equals 0 because we divide both sides by 6. 2s equals 5. 5/2. Okay? So again, both answers. S equals 0. S equals 5/2. Okay? Now, we're on the next, or the third and final IXL. Alright? Now for the third and final IXL, we have to do what? We have to factor first, then set factors equal to 0, then solve. Okay? Alright, so it's really simple. We've done it before. Again, I know it's been a long time since we had to factor, so I'm going to take my time, and I'm going to go ahead and I'm going to try to go in slow motion so you can review how to factor. Alright? So here, remember, you always had to do 2 sets of parentheses. Now we want to know what multiplies together to get j squared. The only possibility was j and j. Then we wanted to know the factors of 5. Since there's only 2 factors of 5, the only possibility can be is 1 and 5. Alright? Now, what we want is we want the smiley face. There's 1j and 5j, and I need it to be 6j, so they're all going to be positive. Alright? So I have j plus 1 equals 0, j plus 5 equals 0, so j equals -1, or j equals -5. Again, those are my two solutions. Alright, how did I know there were 2 solutions again? Because it was to the what? To the second power. Alright, so basically, if they're not factored, you have to factor. Then you set the factors equal to 0. Then you solve. Okay? Let's check out 18. Now, for 18, remember, always you had to first check for a what? GCF. So in this case, there is a common factor. And that common factor is z. Remember, I taught you about the buckets. Alright, and what was common? There was a common z in each bucket. If you pull a z out of the first bucket, there will be 1 z left. And if you pull the z out of this bucket, it'll just be the number 40 left. Alright, now you have it factored. So now you set the factors equal to 0. So z can equal 0. Z plus 40 equals 0. So z could be -40. Okay? So, again, my 2 answers. Z equals 0 and z equals -40. Okay? Now 19. Alright? We're going to do the factoring on this guy. Alright? 2 sets of parentheses because I noticed there was no GCF. Okay? The only possible way I can make 2y squared, remember, is 2y and y. Now the question is, where does the 13 go? There's only one factor of 13. Now what I'm going to do is I'm going to put it in the wrong spot first to review with you. 13 and 1. Now if I do the smiley face, that's 26, and that's 1. 26 and 1 do not make 15. So what I'm going to have to do is I'm going to have to switch these. I'm going to put the 13 over here and the 1 on the right side. Now you can see what I mean. Okay, and what do I mean by that? I can look here. I'm going to make it a little darker for now. I can go here and notice these two together make 13. These two together make 2. 13 plus 2 can equal 15. But I want it to be negative 15. So I want it to be negative 13 and negative 2. All right? So now we're going to go back to negative 13 and negative 1. All right? Now you set those equal to 0. 2y minus 13 equals 0. Y minus 1 equals 0. 2y equals 13. Y equals 13 over 2. Or y can equal 1. All right? So again, you should be getting better. Should be kind of bringing back some great memories. All right? But again, the factoring is really, really, really important. So please do a good job on this. All right? Let's talk about 20. All right, the first thing we should notice on 20 is the what? GCF. Okay? So there's a common Q. All right? There are 2 Q's in this button, so if I pull a Q out, there's one left behind. In this bucket, there's 1 Q. If I pull it out, there will be a 6 left. All right, now you set them equal to 0. And now we're going to solve. So Q could equal 0, or Q could equal 6. Okay? Very nice problem here. All right, don't forget GCF. First thing we look for, GCF. All right? Here, there is no GCF. All right, so we're just factoring. 2 sets of parentheses. The only way I can make y squared is with y and y. Now I want the factors of 8 that make 6. Obviously the factors of 8 that make 6 are 2 and 4. Remember 2y and 4y make 6y. I want them both to be positive because the middle term is positive 6. Now we set them equal to 0. Y plus 2 equals 0. Y plus 4 equals 0. So y equals negative 2. Or y equals negative 4. Okay? Let's check out 22. Right off the bat, I can see a what? GCF here. All right? So there's common D. 22D minus 3. Set them equal to 0. Okay, and so now I have D equals 0. Add 3 to both sides, and then divide by 22. Right, so D would equal 3 over 22. All right, hopefully everybody's okay with that. Let's check out 23. Okay, 23 now is the first time it's a little bit harder. Okay, so let's talk about it. All right, now, again, I'm trying to get the factors of p squared. All right, so what we're going to do is we're going to break it down like I always said. All right, and I want you to remember, I always said break it down to the middle factors, 4p and 2p. The problem with 4p and 2p is that 6 has to be broken down into 2 and 3 or 6 and 1. Now, hopefully remember what I said about this number right here. This 2 either has to go here or here. But if you recall what I said, 2 cannot be or cannot have a common factor with this 4. Because they share a common factor, the 2 cannot go on the left side. Or 2 cannot go on the right side. I either have to put 2 or 3 or 2. But since there's nowhere to put the 2, I know right off the bat that there's no way for the factors to be 4 and 2. So if there's no way for the factors to be 4 and 2, I need to write down this. I need to write down 8p and p. Okay? Now, the reason why I have to write down 8p and p was I demonstrated to you. I demonstrated that the 4 and the 2 can't break this down. Alright, so since the 2 can't fit in either one of those spots, now I want to show you about the 2 and the 3. 2 cannot go on the left side, but 2, because there's a common factor with 8, so I make 2 go over here, and then I'm going to put 3 over here. Now let's see if that helps. 16 and 3. There's no way 16 and 3 can make 47. So after all that, it's not 2 or 3. So now I'm going to have to choose 6 and 1. Now you notice if I try to put 6 on the left side, 6 and 8 share a common factor. So the 6 has to go to the right, and the 1 would go on the left. Now let's see if that's helpful. So here, 1, and this would be 48. 1 and 48 can make 47 if the 48 is positive and the 1 is negative. Alright? So again, if you look at the smiley face again here, this right here is negative 1. That right here is positive 48, which makes that positive 47. Alright? So now after we got it factored, we set the factors equal to 0. So 8p minus 1 equals 0. P plus 6 equals 0. Add 1. Divide by 8. And over here, subtract 6. Alright, so again, my solutions, p equals 1/8 and p equals negative 6. Okay, so again, alright, I'm really super glad we're reviewing this. Alright, now here what I want to show you now is I want to review what we did with u squared minus 36, because personally now we don't have to do the factoring. We can just add 36 to both sides, and then we take the square root. The only thing we need to be careful of is that we put the plus or minus 6. Okay, now somebody like, well, I'd rather factor. Okay, if you'd rather factor, you have to remember that that just factors to u plus 6 and u minus 6, because again, the middle terms would cancel out. Alright, and then we set them equal to 0. And guess what? Same answer. Alright, so it doesn't matter how you solve it. I just prefer this method because it's faster, that's all. Alright? Let's look at 25. Alright. Now another harder factoring problem. So let's practice. Alright. So how do I get 12p squared? Middle factors first, 4p and 3p. Now the only factors of 3 are 3 and 1. So I have to put the 3 somewhere. Alright. I'm going to put the 3. I cannot put the 3 there because it has a common factor with 3. So I have to put the 3 over here. And I'm going to come over here and put the 1. Uh-oh. Sorry about that. I'm going to put the 1 on this side. And now we're going to see if that helps. Alright, so here I have 9 and 4. So 9 and 4 don't make 20. Alright, so now I have to erase. Alright, I'm going to get rid of this. I know it's not 4 and 3. Alright, so now I'm going to try 6p and 2p. Alright, remember, you could try 4 and 3, 6 and 2, or 12 and 1. Alright, so I'm going to try 6p and 2p. And again, the factors of 3 are 3 and 1. Notice again, 3 cannot go there because again it would have a factor with 6. I'll put the 3 over here, and now I'm going to put the 1 here, and let's see what happens. So now we do my smiley faces. 6 times 3 is 18, and 2 make 20 if they're both positive. Okay? So now I have 6p plus 1 equals 0. 2p plus 3 equals 0. So now I have 6p equals negative 1. P equals negative 1/6. Or 2p equals negative 3. P equals negative 3 over 2. Okay, that's a really, really good problem. Really important. Okay? Let's check out 26. 26 is easier again because the leading coefficient is a 1. So let's do the factoring here. V times V, 5 and 2. This is 5 and this is 2. So I want this to be plus and this to be minus. All right. Now we set them equal to 0. V minus 2 equals 0. V plus 5 equals 0. So V could be 2 or V could be negative 5. Again, I always think it's important to check your smiley faces and see that that creates the correct middle term. All right? Let's check out 27 now. All right? So for 27, again, all right, the only way to make 3u squared is with 3u and u. All right? Now the factors of 9, all right? I can choose 3 or 3, but then I would have a problem because there's nowhere for the 3 to go. So that's how I knew automatically it was going to be 9 and 1, because the 9 has to go here, the 1 has to go there, because 1 is not a factor of 3, all right, or 1 is the only factor of 3, okay? Now, we use our smiley faces here. 1, 27. Can make negative 28 if they're both negative. Negative, negative. So now I have 3u minus 1 equals 0. U minus 9 equals 0. 3u equals 1. U equals 1/3. U equals 9. All right? Very good. All right. Now I'm back to 28. Notice that there is no middle term here. So again, I personally like to solve for k squared. All right. Now again, the reason this is a little bit harder is because the numbers are a little bit bigger, but we'll work through that. All right. So I'm going to add 175 to both sides. Now I'm going to divide by 63. All right. Now this cancels. So k squared. Now, this is going to be kind of hard to see, but I know that 63 is 9 times 7. And then I know that there are 7 quarters in $1.75. So I knew that was 25 times 7. Now, if that's something you want to do, you want to just use your calculator. I don't really mind, all right, but I'm trying to, again, show you how you can do good mental math on that. So these cancels. So k squared equals 25 over 9. So now what? I take the square root of both sides, and I got k equals, don't forget, this can be written as the square root of 25 over the square root of 9, so you're looking at them individually. So it would be, don't forget also the plus or minus, square root of 25 is 5, square root of 9 is 3. Okay, so I really would like everybody to take a close look at this right here. All right, and make sure that you understand this step right here. All right, that's critical. All right, and then of course everybody always forgets the plus or minus. So please review that problem. All right, it's been a while since we've had to do a what? GCF, but I definitely see it. There's a common u, so now I factor out the u and I get 49u minus 25. So set them equal to 0. And so u could equal 0. Add 25. 49u equals 25. So u is equal to 25 over 49. All right, so again, those are both solutions there. All right? I don't think we have that much more to do. All right, so 30, 31, and that's it. Okay, 31 is the annoying one. All right, so you got to be real careful. All right, so let's look at 30. Now, the one thing I want to press upon you here is occasionally they'll throw one in where I can look at these and say all of those can be divided by 2. So I want to just divide by 2 first. So now I have 49y squared minus 42y plus 9 equals 0. All right, so again, that's kind of like a GCF. All right, now we could pull out a 2, but to me, when there's just a number involved, the easiest thing to do is just divide out the number. All right, you can never divide out a variable, but you can always divide out a number. All right, so now we're factoring. Of course, we know 49y squared would be 7y and 7y. And then factors of 9 will go with 3 and 3. And then what do you know? 21 plus 21 makes 42 if they're both what? Negative. All right. Now, this again, I'm going to write, and I want everybody to write this down. This is again a double root because the same root is written twice. Okay? That's why it's called a double root. So you only have to solve it once. So 7y minus 3 equals 0. 7y equals 3. And so y equals 3/7. So 3/7 is considered to be a double root. All right? 3/7 is considered a double root. All right? So now, let's look at the last problem. All right, so here we go. All right, now 361 is really obnoxious, and I'm not even expecting you to know that. All right, but I would like, since we're working on square roots, if I take the square root of 361, of course that's 19. All right, so I would have a 19w, 19w. The only factors of 1 are 1 and 1. All right, so guess what? 19 plus 19 makes our 38 if they're both positive. So again, this last problem again is called a double root. All right, so it's just 19w plus 1 equals 0. All right, so subtract 19w equals -1. So w equals -1 over 19. Okay, so again, guys, thank you very much for being patient. Please go do the IXLs now. Take your time, do them correctly. All right, don't use some outside source. You do the problems. I'm monitoring now how long it takes you. I know about how long it should take. And if you're doing 30 problems in 5 minutes, that's not going to do it. Okay? So again, hope you're staying safe. Be honest. Do the work. You got plenty of time. All right, and have a great day.